Hello everyone. Today we are going to solve an exciting problem on multiple squares being stacked and how the side lengths get added up nicely. This is a pattern recognition problem, though it is not a complete part of geometry or combinatorics. It's a meld of both. So let's see how it works. Shown here is the diagram of first few squares in a spiral sequence. The first square has a side length of 1 centimeter and the second one is placed just on top of that. So it will also be 1 because its side matches with the bottom of second one. You have the top of first one coinciding exactly. So due to this overlap, both measures 1. Now we get to start the spiral. The third square is placed in such a way that it entirely overlaps the first and second combined. So it's 1 plus 1. So the side length would be 2. And fourth is placed in order to spiral again, like this. But here the side length of 2 is added with 3. It's stacked in such a way that 2 is added with 3. So therefore 1 plus 2, 3 is the side length of 4. For 5, it is stacked in such a way that its side overlaps with the side of 3 and 4 combined. So its side length will be 5. 3 plus 2. And same argument goes for 6. A similar argument goes for 6. You have 3 plus 5 equal 8 as the side length of it because it is stacked on top of 4 and 5 combined. You could see no space is left behind. They completely cover the bottom part of the square 6. So it's compactly arranged in that way. Now 7 will be 8 plus 5, 13. We can clearly see that if it goes like this, the side lengths are the new side length will just be the sum of the two older side lengths. Now they are asking us to find the side length of 1/1th square constructed this way, like a spiral. You see that there is a spiral thing going on. The length, each new length will be the sum of the two preceding square lengths. So we name AI as the length of square I. Therefore, we get AI equal AI minus 1 plus AI minus 2 for all I greater than or equal to 3. This connotates me of something more fascinating, that is the Fibonacci sequence. It also conforms to this relation and even the initial conditions match, so the sequence thus formed will exactly match or coincide with the Fibonacci sequence. What does that state? The Fibonacci sequence runs as follows. You have 1 and 1 for the first two squares. Next 2 and 2 plus 1, 3, 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 13 and so on. And this is exactly the Fibonacci sequence. Using this recurrence, we build the new terms of the sequence. Likewise, you have to do 101 times. It's a bit computational, but we give full credits even for students who recognize this pattern and just write it as the 101th term of Fibonacci. Just for curiosity, let us also give you the value. Here is the value of the 101th term of Fibonacci, which will be the side length of the 101th square. As you could see, there are no underlying formulas here. We just want students to recognize patterns and find the underlying sequence by themselves and taking their own time. In fact, we give 14 days of time for students to meditate and contemplate over this problem and write their solutions physically. This reduces their screen time. And we also give sufficient time. For 8 problems, we give 14 days of time. This is in fact a fortnight problem of our SuMON Level 1 worksheet. So I hope you will find it enjoyable. You may join us using a trial worksheet for free. You can apply for the trial worksheet through www.sumonmath.com. See you then. Bye.